Hi everyone, welcome back to Brain Lab Techies, and this is Suchana, and this is day 2 of our playlist Complete Statistics for Data Science. Now today the topic is very interesting. Today we will be talking about the data pipeline. So in the previous video we already talked about the DIKW framework. Now today technically we will be implementing how this entire framework is actually used in any real life case scenarios, like in real work, how the data pipeline is actually implemented with this framework. So if you have not watched that video, first complete that previous one and then let's continue from this part. Okay, so let's start our video. So first imagine you are working in a company, like it's a e-commerce company. You are working in an e-commerce company with the strength of 1 million customers. Now you are receiving a data set containing some few factors. So a data set which contains customer age, gender, purchase amount, product category, and location. Now tell me, can you manually analyze this 1 million customer data based on this all these factors? Obviously no. So in the previous video, what we have discussed, that descriptive statistics, like if you have any raw data, descriptive statistics is actually converting this to meaningful insights. So here also we need what? Descriptive statistics to get meaningful insight. Now the question is, what is descriptive statistics? So as a definition, we can say, like, it is the branch of statistics. Obviously, we can classify statistics in two ways, right? One is descriptive one and another is inferential. Now this descriptive statistics is what? This is branch of statistics that help us in three ways. One is summarize, second is organize, and third is visualize. So summarize, organize, and visualize the data. So if you have this 1 million customer data on this different factors, your descriptive statistics is here to make it into meaningful insight. So that is how it can simplify the large data set. Now let's understand the life cycle of data or the data pipeline. So in this life cycle of data or the data pipeline, so this is, you can say, the technical perspective of this DIKW framework. So what we can say, so technical implementation of this DIKW framework. So what's the first step? First step is data generation, means somewhere data is getting generated, right? Now from that generated data, what is happening? Your collection of data is performed, because if we're going to analyze those data, we need to collect the data first. So the step one is very important, which is a collection of the data or the data collection. Now here, data storage, like whenever we are collecting the data, means we need to store the data somewhere. So data storage is also important. So here in this portion, like data generation, you know already how the data is getting generated whenever you're clicking some applications, whenever you are like surfing through the internet, whenever you are watching about the reels, whenever you are texting, every time data is getting generated. Now how this data can be collected? Now data can be collected through inquiries, through surveys, through census data. So here we need some forms, like whenever you are doing some sign-ins also in some applications, there's some data collection is actually appeared, right? So it's happening. So you are actually filling some forms. Now with the help of the forms, data collection is happening. Now if it is directly, it can be done through surveys. Now otherwise also, like data collection, so after collecting the data, data is stored somewhere. So after collection of the data, data is going to store somewhere. So in which format? Like it can be in the format of CSV, it can be in the format of JSON, Excel, SQL databases also used. Even in cloud also we can have those data. Now, when as a company we are collecting data directly from the user, if we collect the data directly from the user, that data is actually considered as the primary data. Means this is more original because we are taking or collecting the data directly from the user. Now, whenever we are focusing on some storage, data storage means already this survey performed earlier in the earlier time, and now it is getting stored somewhere. We are making use of those stored data. Now, those data are not directly collected from the user, those are already collected by someone else. We are just using them as a third person. So here this type of data will be considered as secondary data. Now we can access this kind of secondary data through API or by web scraping. We can directly use. But in the point of reliability, this is the originality. Like if it is primary data, so it will be more reliable. Whereas this stored data, if it is secondary data, means if we are gathering those data from any databases, then those data maybe it consists of lot of redundancy and inconsistency will be there in the data. So in a word, what we can say, the data will be messy. So to learn about that secondary data, let's see some examples of secondary data. So let's go to the browser and search for the biggest repos that mostly data scientists or data analyst or any researcher students mostly use, that is Kaggle. So you have to click on the first link of Kaggle, kaggle.com, and you need to log in. So after login, you will be getting this type of page, and here you can simply search. So I am searching Titanic Dataset, which is a very popular dataset, and in this repository, this is the biggest repository in terms of dataset because lots of dataset already stored here. Simply you can download them and you can use in your projects, in your daily practice. So this is all the dataset. You need to put this filter dataset, and then I'm clicking on the first option, that is Titanic Dataset, and as you can see here, download button is there. So I'm just clicking on download, and here this download dataset as zip. So this is available as zip, so I'm just clicking on it. So it's already downloaded. Now let's go back to the folder, and here I have this data set. So let's unzip it. So I'm extracting this in the same folder. So now this tested, this is the data set we already have downloaded. Now this is the CSV format. What is a CSV? CSV means comma separated values. So here, as you can see, all the entries are separated by comma. So this is what your comma separated value, and mostly whenever you will be doing data analysis, most of the data will be look like this CSV format. Now how to work with this CSV? So let's go for the next thing, that is Colab. So we will be using Google Colab. Mostly data analysts use Google Colab. Here, this is one online platform. Here, you can do simply, you can write Python code, and in the cloud, it will execute. So, make sure your network should be good enough. Okay, so this connect option you need to check on. and after that I'm just putting the file. So this is where my file is tested is the data set. So I'm just drag and drop this file. So as you can see, one warning message is coming, so you need to click on OK. So now you successfully downloaded and imported this inside this online platform Colab. Now you need to use it inside your project. So how to use that? So for that, to import this data set, you need to take use of one library for data analysis. So I'm importing Panda. So just you need to write import pandas as PD. Simply run on. See, it's already executed, means already we successfully imported Panda. Now, what's the next step? We need to name this data frame. So this is also called data frame. So I'm writing df equals to, you can simply write data as well. This is just a variable name to name this CSV file. So now I will be writing pd dot read CSV underscore CSV. Now just put this single quote and copy the file path. How to copy the file path? Just click on this three dot and just copy the file path, and you need to paste it here. So now click on this run and see it's successfully executed. Now if you need to check what are the rows and columns are there in this data frame, simply you need to write this head method. So this is, if I write 5 means I will be getting 5 rows from the beginning of this data frame. So as you can see here, this is the output, and here lots of columns are there starting from passenger ID, survived, P scale name, and so on. And how many columns are there? So if you're going to know about this, I will be using here df.shape. So what it will do, it will give me this value 418 comma 12. So what is that? This first one is giving me the number of rows present, means how many entries are there. So to all total 418 entries are there, and this 12 is basically, 12 is nothing but this is actually the number of columns present inside this data frame. So now this is properly a secondary data, means we are just downloading and using it from a secondary source. We are not going to like collect it from the primary source. Indirectly we are taking help from a secondary database. Now, as because this is a secondary data set, I already have told you that secondary data set always deals with so much redundant data, duplicate data, inconsistent data. So the data is messy. So let's check whether my data is messy or not. So for that, first thing we will be doing the df.info method we will be using. Now execute this, and here you will be getting all these 12 columns with some metadata. Now what it is telling us, this non-null values means all the values present inside this individual column. So as because like already we have executed this shape, so now you know this 418 columns, sorry, rows are there. Now 418 entries or information, different information is there. Now here, as you can see, passenger is also 418, survive 418. But if you observe this age column here, 332 means rest of the values are null values, means missing values present. Okay, now how to check the missing values? If you're going to count all the missing values, simply what you have to do, df dot is null. You will be using is null, and after then, yes, this is the thing, is null dot sum. So what it will be doing, it will sum up all the missing values. So here, as you can observe in the output, age is having 86 missing values, and this fare is having one missing value, cabin is having 327 missing value, means the data is not at all cleaned. This is messy data. Now, before doing some analysis, we need to clean the data first. Okay. And mainly we clean the data for model training purpose. Now, the thing is, whenever we are working with secondary data, the next step always it will be what? Data cleaning. Data cleaning is important. So this is our next step, data cleaning. So after data collection, if the data is particularly collect like you are collecting from secondary data set, means you have to do what? Data cleaning, because data can be messy, as you can see from this example. I hope you understood. Now the next thing, this data cleaning. Now for this data cleaning also you need to make use of some descriptive statistics measurement. Here you need to use what? Descriptive statistics measurement. Now later we will be seeing how many techniques of data cleaning is there. We will be doing it thoroughly. But here the main thing is this logic, this descriptive statistics measurements we need to know for this data cleaning purpose. After then in the next step, we can simply do EDA, which is actually exploratory data analysis. Now in this exploratory data analysis also you need to take help of descriptive statistics. Now this much important it is. Now this is not the last thing of your data pipeline, because this is all about your data analysis. Now what about your model training? Suppose you are going to train some machine learning model, you going to train some model with some machine learning algorithm. That time after this part you need to do some more options or techniques you need to perform. So that time in this data pipeline is very important part is feature engineering. Now this part is very important for your machine learning journey. So in the data pipeline, after data analysis, if you are going to train the same thing, the entire data set for a model, you are going to train a model on that particular data set, that time you need to do what? Feature engineering. So there you need to do some data transformation here. Now after data transformation means your feature engineering performed, then we will be coming to the main part, that is your model evolution and building, means model training. Model training and evaluation. Now in this evaluation also lots of descriptive statistics measurement we will be using here to calculate the error, how much your model is doing error. There also we will be using some measurements of descriptive statistics. So here also you will be having some applications of descriptive statistics. Now after model training, do you know what is the next step? This is not the last step, because after you finish the training of your model, the the main step is left to do. That is what your model deployment. Because after training the model, that is not the last step, you need to deploy also. So model deployment also is important. So that will be done with the help of MLOps. Now those videos also will be coming in the channel, so stay tuned for that. And if you are very new to the channel, let me tell you that machine learning playlist is already there in the playlist, like in the channel, it's already going on. So go and watch those videos. Already machine learning playlist is conducted by Sugam sir. So go and watch that video. Simultaneously, you can learn the statistics and machine learning. And model deployment will be coming in MLOps playlist. Now, after this deployment, there are also few steps which is not like most of them will Ignore the part, but this is also important, that is improvement, model improvement and maintenance. This is also important. Now, this is the entire data pipeline, and these are all the part where you will be using your data. Processing portion means the descriptive statistics. So in the next video, I will be telling the descriptive statistics measurement. So that's all for today. See you in the next video. Bye bye everyone. Take care and thanks for watching.